Welcome to part 3 of Competency 11. In this video, we will work with dilations and scale factor. Number 1, triangle DEF prime has a hypotenuse with a length of 65 units, which is a dilation of triangle DEF below. What is the scale factor using the transformation triangle DEF to triangle DEF prime? Okay, so if you think about it, looking at the length of the hypotenuse, we're increasing. So it's going to be times a whole number. Well, we have a whole number or let me just say, a value greater than 1. Well, that would eliminate A and B. So I'm thinking A and B are out just because of the properties of going from a smaller triangle up to a larger one, because 65 is going to be larger, just eyeballing. However, let's not guarantee ourselves there. I'm looking at this triangle and I see a 5 and 12, legs of 5 and 12. That tells me this is a primitive right triangle and the hypotenuse is 13. There are some primitive right triangles. Look them up on Wikipedia and make sure you familiarize yourself. I teach the kids this. So we have the 3, 4, 5, very popular in testing. Then we have this one, that's the 5, 12, 13. And then there's another one that is a 20, 21, 29. Okay, there are other ones. Okay, there's a list. Okay, but I just teach my students, I make out like a list of about 5 or 6, put them up on the board, and everybody should know to recognize them. Okay, but that doesn't matter. You're taking a test, you don't recognize it. Who cares? Okay, let's just put it in the calculator. Second radical, okay, 5 squared plus 12 squared gives us 13. Now, well, we have to go from 13 units to 65 units. So we simply divide. 65 divided by the 13 gives us a scale factor of 5, which actually makes sense. Okay. All right, so let's go to number 2. Okay. A polygon P with an area of 27x yards squared is dilated by a scale factor of 3 to create polygon X. What is the area in square yards of polygon X? Okay, when we talk scale factor and we're talking about area, the first thing you need to do is make sure that you tell yourself area is squared, so my scale factor needs to be squared. You simply do not have a choice, okay? Now, that's a scale factor, so you're going from an area to another area. Okay, so that's 27 times 3 to the second power. Okay, so let's give it a go. 27 times. Don't worry about the X. He's just hanging it in there for the ride, okay? We don't know what X is yet, okay? All right, so we're just taking the values themselves, because whenever X is known, it'll be multiplied to the value we get. Okay, so that's times 3 squared, enter, and that gives us option D, which is absolutely correct, okay? All right, let's go on to number 3. Number 3, a rectangular soccer field and a rectangular garden are similar in shape. The dimensions of the soccer field are 3.2 times the corresponding dimensions of the garden. Which statement is true about the two rectangular shapes? Okay, here's the thing. Look at A and B. If we are talking about perimeter, that would mean that we would keep 3.2 as is. You would apply it That means multiply it to the dimensions and keep it because you're going to increase the perimeter only. Okay? So look at A and B. That is not what they have done. Okay? A incorrectly applied 6.4, and that means that they said they applied 3.2 times 2. That is not how we apply scale factor. Okay? Scale factor for the perimeter is one dimensional. That means that it's simply to the first power, so we keep it as is. Now, let me mark out B because we're not using it, because what they did, which I'll get to here in C and D, okay? For area, that means we would apply 3.2 squared. Now, if it were volume, it would be cubic. So what do we actually have to multiply? Okay, and they're using the word times, which is layman's for multiply. Okay, it's not really a good math term, but it's a term that we see. Okay, so that's 3.2 squared, enter. Okay, 10.24. That gives us D, okay, which is correct because that's what we applied to area. So we applied it to the area of the soccer field in order to get the is 3 times the area. Well, we applied it to the garden to get the area of the soccer field. Okay, either way, that's what we know that we need to do. Okay, when we were talking about area. So C is incorrect. Okay, and as we can see, okay, that's not how 6.4 would be times 2, and that is absolutely not how we deal with scale factor and area. Okay. All right. So let's go on to number 4. A quadrilateral triangle has a perimeter of 24 centimeters. If the triangle is dilated by a factor of 1.5, what is the perimeter of the new triangle? Okay, here again, they are talking about perimeter. So what I said above is what we need to do. We keep it at the first power. It is one dimensional because of perimeter. So you apply it as is. Do not square it, do not cube it. Okay? So that is simply 24 times 1.5. Okay? Which is 36, and that is valid. Okay. Now, you can look at the other options that you're given. Looks like they took, for A, that's 24 divided by 2. That would be applying the scale factor as half. Well, they didn't say any of that. Okay. And 1.5 is 3.5. So be careful when you're looking at these other items. They're trying to trick you visually, okay, and get you to confuse you. So if you multiply or divide or do something other than applying a scale factor, squared or cubed. Now, I say that when we're increasing, but they didn't say about decreasing. If the triangle is dilated by that scale factor, well, that scale factor's perimeter, and it is 3 over 2 or 1.5. Okay, I'm just trying to set you up to read them correctly. Okay, all right, so let's look at number 5. All right, which of the following represents the equation of a line in the xy plane that is the reflection of the line y equals 3x minus 1 about the y-axis? Let me show you what they're doing here. So let me draw it quickly. And remember, my drawing is questionable, so don't expect a thing of perfect beauty. All right, so the first thing I did is I looked at the line itself. And I noticed that all of my A, B, C, D options all have the same B value. Well, that makes life pretty convenient. That means I have to, when I reflect, I have to have my dot, my line going through the -1 here. Okay. Well, that's not bad. Now, and I also know that my line has a slope of 3 over 1. It's a positive 3 over 1. So I take my line and I sketch it up. It's not perfect, but it works. Okay. I'll buy it. Right. Now look at A. A is just repeating this. Well, A could technically, that would be like technically saying you have one line on top of the other. That's not what the question asked. So mark through that if you see it. Okay. Now, another thing that I see, look at option D, -1/3. That would be a perpendicular line. Okay. Perfectly perpendicular. Perfectly perpendicular is not a that is not a reflection about an axis. So be careful. There is a difference, okay? And I'll draw that after we answer the question. So I'm saying D is not going to work. So I'm going to mark through that. Okay, now let's talk about what this really should look like. What you're doing is you're still going to have a line going through -1 because they say so in the options, okay? Then what's happening is, as we talked before, everything that, let's say, everything in quadrant one, we know that it is going to be rotated and end up rotated about this y axis and end up in Q1. And everything that is in Q, let's see, everything down here, this part right here, that's in Q3, that is all going to end up over here in Q4. Okay. Just a very simplistic way to quickly look at it. So when I rotate this line around, think about it. Take a stick and rotate it around. Okay. You will end up with something looking like this. Now pretend, oh, big stretch again with my drawing, but I think I can get the gist of it across. Okay. You're gonna end up, oops, like that. Oh, goodness gracious. There, something like that. Okay. Let's go with that. Yeah, it's just like like it's a unusual, like tornado looking effect, but you have that bottom and top rotating around. Like take a straw and make it rotate around, and you can kind of see that. Okay, well, that being said, that gives us the negative value. So all that's telling me is that I need C. I need the positive slope to become a negative slope. Okay, now let's go back and talk about D. What would D have looked like? Okay. And B simply doesn't make sense. Okay. Because that would be a totally different slope, kind of like coming, it would be a positive slope. It wouldn't be a reflection about the y axis. It just kind of like would tilt it different. It would be like a tilt. And we don't want a tilt, right? So let's get rid of that. Now, I want to talk about D. What would that look like? So here, let's get a different color here. Grab something different enough, like this purple here. Here we go. What we need, that would actually be, you would have to come out like this to create a perpendicular situation. So let's say they gave you graphs to choose from, and you saw something that had a 90-degree and they're talking about a reflection about an axis, automatically you know that is just not going to, it's just not copacetic. It's not going to jive. It's not going to work. All right, this is the last question in this video. I know I rambled a little bit, but we don't have quite enough questions in our repertoire yet. Okay. So I want you to have enough if you have to take your test quickly and you don't have time to watch other videos. Okay. It will come up in other videos. All right. Okay. Thank you for watching and liking and sharing. Oh, and thank you so much for subscribing. Happy testing, everyone.